We are told that the eighth term of a geometric series is 576 and the ninth term is 2304. We're going to work out what the fifth term of the sequence is. Now to do that we need the ratio, the common ratio that's applied to each term to get the next term. We know the nth term of a sequence, geometric sequence, is given by a to the rn minus 1. So the eighth term is ar to the 7, that's 8 minus 1, and the ninth term is ar to the 8, which is 9 minus 1. So to get the common ratio, you could do term 9 divided by term 8, and that will leave you with the value of r. And this is always true, that if you know two consecutive terms, you do the next term divided by the preceding term, and that will give you the value of r. Let's work that out now. So the common ratio of this geometric sequence is 4. Let's draw out what we've got. So if this here is the fifth term, then we've got the sixth, the seventh, the eighth term and the ninth term. We already know that the eighth term is 576 and the ninth term is 2304. We know the common ratio now is 4, which means that these terms get multiplied by 4. So the fifth term is the 576 divided by 4, divided by 4, divided by 4. So we can draw it out and work out the value of T5. So here we have that the fifth term is 9. We could also calculate this a different way by first working out what the value of A is. Let's do that now and see if we get the same answer. We know that the eighth term is 576, and we know that that equals A multiplied by R, which we've calculated as 4, to the power of 7. So we can work out the value of A by doing 576 divided by the 7th power of 4. That's 9 over 256. And now we know that the fifth term is given by AR to the 4. So the fifth term is going to be 9 over 256 multiplied by 4 to the power of 4. And that should give us an answer of 9. Here we have another geometric series. The sum of the first 5 terms of the series is 275, and the sum to infinity is 243. And there are these two formulae that are in the formula booklet that we're going to need to use to solve this, to find the common ratio and the first term of the geometric series. Well, the first thing to note is that for there to be a sum to infinity, r, the common ratio, must be between -1 and +1, or we could say the modulus of r has to be less than 1. Otherwise there will be no sum to infinity. Let's use these formulae to find the first term and the common ratio. Now we have these two equations, we want to solve them simultaneously. Well, can you see here that 243 is a over 1 minus r, and that's the same as this part of the equation on the left. That is, on the left hand side we've got 275 is the product of a over 1 minus r and 1 minus r to the 5. And we know that a over 1 minus r is equal to 243. So I'm going to substitute this value, 243, into this equation. And now I'm going to rearrange and solve this equation. Here we have the common ratio that r is negative 2/3, and now we need to substitute that into one of these equations to get the value of a. This one looks like it's much easier to substitute into. So here we have the first term of 405 and the common ratio of negative 2/3. A rich businessman makes one donation per year to a certain charity. He starts by donating £100 in the first year. In each subsequent year, the value of the donation is 1.2 times the value of the previous year's donation. We want to find the value of the businessman's donation in the 12th year to the nearest pound. So we could just work it out each year and start adding that together, but there must be a more efficient way, and that's using a geometric series. So we know that a is 100 and we know that the common ratio is 1.2. So in the 12th year, this is our 12th term, we can use the nth term to work it out, which is given by a r n minus 1. So here the 12th term is going to be 100 multiplied by 1.2, and that's 12 minus 1 is 11. So we put that in a calculator and it will give us the value. So to the nearest pound, this is going to be 743 pounds. Now, after receiving the nth donation, the charity's treasurer calculates that over the years, the businessman has donated a total of £15,474, correct to the nearest pound. Let's see if we can find the value of n, that is, how many years has the businessman been donating to the charity? Well, the formula booklet gives us this formula. We can use this formula to help us to calculate the number of years, that is the value of n. We know that the sum is 15,474. We know the first term is 100, and we know the common ratio is 1.2. Well, let's rearrange this and have our power of n to work with. Here we can bring the power down by using logs, and that would give us the value for n. So here we can see that the businessman had been donating for 19 years.